Hi, everybody. We're going to look at numbers 6 through 10 now from this ALEKS review for topic 6. Here we have number 6. And again, the problems that you see in ALEKS are likely going to be different from the ones that pop up for me during this review, but they should be very similar in terms of how you solve them. Number 6, where it says to use the substitution method to solve the system. Now, when you're taking the test, if you see a problem that says use substitution, you could use other methods like the elimination method, but if it says use substitution, that's probably a good indicator it's going to be our easiest method to use. Here I see 5x plus 2y equals 30. That equation is written in standard form. 5x plus 2y equals 30. Below that, we have 3y minus 11 equals x. Now, that's interesting. X equals 3y minus 11. See, because we're told what x equals, we can substitute 3y minus 11 in place of x in this first equation, and that's what I'm going to do. So I have 5x, I'm going to write 5, but then instead of putting x there, I'm going to replace it with 3y minus 11. We're substituting that in where the x is in the equation as written. And then I have plus 2y equals 30. Really, I've just rewritten that top line there, that top equation, but replacing the x with 3y minus 11. What that gives me is an equation that only has one variable in it. The y terms are all that remain here, no more x's. All right, so now what I need to do is I need to handle the parentheses here. This 5 in front of the parentheses, it's being multiplied by this. I'm going to use the distributive property, or as I like to say, bomb the fort. And let's do that. 5 times 3y is 15y minus 5 times 11, which is 55. Then I have plus 2y over here equals 30. I have two terms that have y's in them, but I can combine them together because they are both on the left-hand side of this equation. So 15y plus 2y means I have 17y altogether. We still have minus 55, and it equals 30. Next step, let's get our y term to be by itself. And we can do that by adding 55 here and also on the right. Whatever we do on the left, we have to do the same thing on the right side of our equation. So 17y equals 85. Now you may use a calculator for this last step. I'm just going to go ahead and divide by 17 here and here. And I happen to know 17 goes into 85 exactly 5 times. Y equals 5. And now that I know what y is, I can find x actually using this equation right here. X equals 3y minus 11, that second equation. So I'm going to use that. X equals 3 times y, that's 3 times 5. See, we just found what y is equal to, minus 11. So x then equals 3 times 5 is 15 minus 11. Therefore, x has to equal 4. Now, you do have to be careful when entering these in ALEKS because you don't want to put them in backward. X is equal to 4. That's the one we found second. Y is equal to 5. That's the variable we found first. Okay? And so I'll hit check, and sure enough, I have number 6 correct. All right, number 7. Use substitution to solve this system. Look how similar this is to the last one we just did. We have x equals 3y minus 2, and then our second equation, which is in standard form, 3x plus 4y is equal to 20. What I'm going to do is, since I'm told x equals 3y minus 2, let's put 3y minus 2 in place of the x here, and just rewrite that second equation. So 3 times x, that's 3 times 3y minus 2. That goes in place of the x, plus 4y equals 20. Now I use the distributive property. I need to bomb the fort here. 3 times 3y, that's 9y, minus 3 times 2, that's 6, plus 4y equals 20. Now, I can combine my y terms. They are both on the left side of my equation. So 9y plus 4y is 13y. I still have minus 6 here, equals 20. Then I add 6 here, and also on the right side I add 6. That eliminates this and leaves me with just 13y over here on the left side of my equation, and it equals 26. Then I divide by 13. Each side gets divided by 13. Y is equal to 2. If I ever get going too quickly for you to keep up, just pause the video. You can always rewind and go back and see how did I do that last step. All right, so now the top line, x equals 3y minus 2. Now I know what y is. I just found it's 2. So x equals 3 times 2 minus 2. So x has to equal 6 minus 2, which is 4. Okay, now again, be careful when you enter these in ALEKS, get them in the right order. X equals 4, y equals 2. So here x equals 4, and here y equals 2. Okay, then I can click check, and there we have it correct, and I'll move on to number 8. All right, number 8, solve this system of equations. We have 2x plus 4y equals negative 8. We have negative 2x plus 3y equals 22. Now I'm noticing right away in my top equation 2x and in my bottom equation negative 2x, those are opposites of each other. And so I can use the elimination method for this problem. 2x plus 4y. I'll just rewrite these over here. Equals negative 8. And then negative 2x plus 3y equals 22. So I'm going to add these together, which will cause the x's to be eliminated since they're opposites. 2x plus negative 2x is 0. Now my y's, when I add these, 4y plus 3y is 7y. And that equals, here be careful with your negative signs, negative 8 plus 22. That really means 22 minus 8, which is 14. Okay, so 7y equals 14. Now I just have to divide each side by 7. And I get 1y is equal to 2. Now that you know what y equals, let's put it into that top equation to find x. So 2x plus, and then it says 4 times y, so that's 4 times 2 equals negative 8. 2x plus 8 equals negative 8. Now be very careful here. We're going to subtract 8. That's the same thing as adding a negative 8. And I need to add negative 8 over here as well. So 2x equals negative 16. And then we divide by 2. X equals negative 8. It's most likely if a person makes a mistake on this problem, it's going to be with the negative signs. So we do have to be really careful about those negative signs. So x equals negative 8. I'll put that in here. And y is equal to positive 2. I'll put that there. And I'll click check. It's correct. And I move on to number 9. All right, number 9, we have 6x plus 7y equals 4. And then we have 6x plus 9y equals 12. Hopefully you're already noticing these 6 x's are the same. So I'm going to use the elimination method on this one also. The problem is if you go to add these, 6x plus 6x is 12x. That doesn't remove it. Instead, it doubles it. So what I need to do is actually subtract these. And subtracting is the same thing as adding the opposite of a number. So what I'm going to do is change all of my signs in the second equation. Effectively, I'm multiplying that entire equation, every term, by -1. This becomes -6x. This becomes -9y. This becomes -12. All right. Now I can add these together, because adding the opposite of all of these is the same thing as subtracting them. 6x plus -6x is 0. It's gone. 7y plus -9y is -2y. We have 2 more negatives than we have positives here. And it equals 4 plus -12. We have more negatives than positives. 8 more to be exact. So it equals -8. And then I divide by -2 here. I divide by -2 here. Anytime you divide a negative number by a negative number, you get a positive result. So positive 1y equals positive 4. -8 divided by -2, it'll be positive 4. All right, now that I know what y equals, let's put that into either equation. It doesn't matter. I'll go with the top one. 6x plus 7 times y, which we just found out is 4, equals 4. All right, I'm just checking over here. I did copy it correctly. So 6x plus 28 equals 4. Now I want my x's to be alone or isolated, so let's subtract 28 here as well as here. That's gone. 6x equals -24. 4 minus 28 is the same exact thing as 28 minus 4, except it'll be negative. Then I divide by 6 here and here. X equals -4. So x is -4, y is +4. Now put those in over here. -4 for x, +4 for y. And then I click check. And sure enough, it is correct. So I'll click continue. And this should bring us to number 10, which is a word problem. And I don't want you to get scared by these word problems. They really aren't too bad. You just have to figure out how are you going to write equations for this situation. At a basketball game, a vendor sold a combined total of 136 sodas and hot dogs. So let's call the sodas S. Let's call the hot dogs H, because those are good variables to represent those two things. And they sold a total of 136. So I'm going to say S plus H, the sodas plus the hot dogs that were sold, equals 136 total items. Okay? And I wonder if I can scroll over here. Yep, the number of sodas sold was 3 times the number of hot dogs sold. So the number of sodas sold, I'm going to call that S, is equal to 3 times the number of hot dogs sold. So 3 times H, 3 times the number of hot dogs sold, will equal the number of sodas sold. Okay? That right there is really helpful, because now what I can do to find the total number of sodas and the total number of hot dogs sold is just substitute 3H in for S in that first equation. Excuse me. So I'm going to do that, and I get 3H plus H equals 136. These can be combined, and I have 4H, because remember, this is really 1H here. And that equals 136. And then I divide by 4 here and here. Yes, you may use a calculator. H equals 34. Okay? So since H equals 34, that means there were 34 hot dogs that were sold. See how nice it was that I used H for my variable? Now, if you want to find S, you have 2 choices. You can either take 3 times 34, the number of hot dogs, or you can subtract 34 from 136, which I think would be easier, and you find out there are 102 sodas then that were sold. Man, I can't stop coughing all of a sudden.